This is Ranjit, working as Assistant Professor, Department of Computer Science and Artificial Intelligence, SR University, Warangal. In this session, I would like to explain IP addressing, subnet mask and subnetting. In my previous videos, I demonstrated different network connecting devices using Cisco Packet Tracer, where I used different IP addresses. So, but here I will explain in detail about the IP addressing and use of subnet mask and subnetting. So IP address, it is a numerical label or a numerical number assigned to the system or the device whenever it is connecting to the internet. So over the internet, when a system want to communicate with other system, those two systems must have IP address as well as the MAC address. So MAC address is nothing but a physical address which is permanent address assigned by the manufacturer. So IP address is not permanent address whenever it is connected to the network. So depending on the network to which it is connected, IP address will be allocated. And IP addresses will be allocated statically by the administrator or dynamically by the DHCP server. And there are two types of IP addresses, IPv4 and IPv6. IPv4 means V stands for the version. The most commonly used IP address is IPv4. So that's why IPv4 can be directly called as a IP address. So whenever this IP address is exhausted, then IPv6 will be used because IPv4 size is 32 bit in length. IPv6 is 128 bit in length. So at most 32 bit in length means 2 power 32 addresses can be generated. So when these addresses are exhausted, so then we go for the IPv6, which generates more number of addresses compared to the IPv4. These 32-bit address, and these 32 bits will be divided into 4 octets. So let us see. This is an example for the IP address. Here IP address divided into 4 parts. We call these parts as octets, and each octet size is 8 bits. Means this can be represented in 8 binary bits. This is in 8 binary bits. Like that, each octet represented in the 8 binary bits. So whenever we are writing an IP address, that can be written in the decimal numbers or in the binary numbers. So decimal numbers are convenient for us, but whenever it is submitted to the network internally, digital devices uses binary representation only. So here this is an example for the binary representation also. So here 75.48.35.78, this is one IP address represented in the dotted decimal representation. The same thing can also be represented using the binary numbers. Like this 75 converted into the binary, like 01001011. 45 converted into binary. Similarly, 34 and 78. So like this, IP address can be represented using decimal number or binary number. So now coming to this IPv4, this is most commonly used version of the IP. So IP stands for Internet Protocol. Sometimes we can also call it as Internetworking Protocol. So because when data travels from one network to the another network, so this IP address will be very useful to confirm the route over which the data should be traveled from one network to the another network. So these IPv4 addresses are again divided into 5 classes, class A, B, C, D, E. Like this, it is divided into 5 classes, and each class again divided into 2 parts. network ID and host ID, or network part or host part. Look at this class A address. Here each address class A, B, C, D, E. Each IP address length is same, that is 4 bytes. Each byte length is 8 bits, total 32 bits. In the class A, first byte represents network address, remaining 3 bytes host address. That means first byte means 8 bits. So 8 bits means so total 2 power 8. So that is so 256. Means whenever we are using this class A address, so total 2 power 8 means 256 networks can be created. And in each network, these many number of hosts. What is the host part? So host part 3 bytes. 3 bytes means 24 bits. So then 2 power 24. So these many number of systems can be connected to one network. That means we are using class A means total network 256, and in each network 2 power 24 systems can be connected. So that is the meaning of this network ID and host ID. Network ID used to represent identify the network, and host ID is used to identify particular host in that network. So now similarly coming to class B. So in the class B, first 2 bytes network ID, last 2 bytes host ID. First 2 bytes means 2 power 16 networks, and in each network 2 power 16 host addresses. And coming to the class C, first 3 bytes network address, first 3 bytes means 24 bits. So 2 power 24 networks can be generated, and in each network 2 power 8 systems can be connected. So this last byte represents host ID, only one byte, that is 2 power 8. So this is exactly opposite to the class A. Now coming to class D, this is multicast address. So multicast means in a network, in a group, message can be delivered to all groups, not to all systems connected to the network. For example, network has some 100 systems. In that 100, so different 10 groups are there. So to a particular group which consists 10 systems, if you want to send the data, then we can use this multicast address. And last address class C, this is reserved. So in general, we use only first 3 addresses, class A to the class C. So here each one divided into now 2 parts, network ID and host ID. Then how to identify whenever an address is written, whether it belongs to the class A, B, C, D, or whatever it is. So that will be identified based on this. So look at this. Either we can represent in the binary or decimal. Decimal is the convenient for the human being. So that's why mostly we work with the decimal representation. So whenever an address is written, it consists of 4 parts in 4 bytes. So in the first byte, whatever the number is written, based on that number, its class can be identified. So for example, so look at this first address is 10.10.10.1. So your first byte is 10. So 10 lies in this range 0 to 127. That means the first address belongs to the class A. Similarly, 192.168.10.10. So 192 means that lies in the range, this range 192 to 223. So that means this address belongs to the class C. Like that, whenever an IP address is written, so based on the first byte, that lies in which range, either 0 to 127 or which range. If it is in the 0 to 127 class A, 128 to 191 class B, 192 to 223 class C, likewise. Similarly, if the same number, same IP address represented in the binary, so if the first bit is 0, class A, first two bits are 10, class B, and first three bits are 110, class C. Likewise, if it is represented in the binary, so by using these values, we can identify the class of that address. So if it is represented using the decimal, so by using this range, so we can identify to which class that belongs to. Okay. So in this way, we can identify whether the given number is a class A address, class B address, or class C address. So each address divided into two parts, a network part and a host part. For example, we need less number of networks. In each network, more systems we need. So then we can go for the class A address. So here 50-50 address means 2 power 16 networks, 2 power 16 hosts. So then you can go for the class B. For example, here more number of networks we need, and in each network only few systems are needed. Means if the network size is very small, so then we can go for the class C. So likewise, depending on our requirement, so we can choose any of these classes of IP address. Now coming to the subnet mask. So at the time of DHCP server simulation, I told you that whenever a system is connected to the network, IP configuration details will be assigned by the server, like IP address, subnet mask, default gateway. So this subnet mask is also essential whenever a device want to communicate with the another device. So this subnet mask size is also equal to the IP address in length. So its length is 32-bit, and it is used to separate IP address into two parts. Nothing but it is used to identify which part is the network ID part, which part is the host ID part in the IP address. Based on using this subnet mask, a network device can identify which part is network ID, which part is host ID. So based on that, so it will confirm that on which network destination is available. And it will also use it to divide the network into small subnetworks. So we discussed this, how to divide that into subnetworks, small networks. And if it is not, what is the problem? This we discuss later. But here the subnet mask means based on the subnet mask, the router can identify or decide on which network this destination is available. And its subnet mask length is 32-bit in length, equal to the IP address. So let us see. This is an example. If this is IP address is written 192.168.1.10. So 192 means this lies in the range 192 to 223. Means class C address. So class C address means first 3 bytes represents network address, last byte represents host address. Just back I explained. First 3 bytes network address. So then in the subnet mask, first 3 bytes should be written with maximum number. Because each IP address in each part means each byte starts from 0 to 255. 255 is the last number. That's why your last number is written here 255, 255, 255. Because this is the class C address, and here first 3 bytes represents network ID. That's why in the subnet mask first 3 bytes written as 255, 255, 255. And last part is 0. Last byte 0 in the subnet mask means the last byte in the IP address represents the host address or host ID. And this part 255 means again this part in the IP address represents network ID. This is decimal representation. Now we represent same thing in the binary. This you 192 convert into binary, 168 and 1. So these three bytes represent network ID. That's why in the subnet mask, first 3 bytes written as all ones. All ones are here 255, both are same. This is binary representation. This is decimal representation. So here last byte 10, so 10 represented in the binary. This is host part. That's why in the subnet mask, in the host part, all 0 should be written. So in the subnet mask, some part is written as 0, total zeros. That means in the corresponding part of the IP address represents host ID. Remaining, if it is all ones, this part in the IP address represents network ID. Okay. So this is about the subnet mask. So using with this subnet mask is available in the router. So router will perform some operation. So between subnet mask and the destination address. So based on the result, it will be decided on which network so and so system is available. So that I will show you. But this is about the subnet mask and the role and importance of the subnet mask. So now coming to the subnetting. So subnetting means it is a process of dividing the network into small networks. So why we need to divide that into small networks means. So let us take class A address. In the class A address, around 16 million hosts can be generated in one particular network. Just like I told you, in each network we have 2 power 24 systems will be there. Means 2 power 24 addresses can be generated in each network using a class A. So 2 power 16 means it will be difficult to manage such type of huge network. And there will be some security issues. And generally in one network, these 16 million systems may not be used. So those many number of addresses will not be used. So definitely some address space will be wasted. So managing that such type of huge network is difficult. Security issues will be there, and generally we won't use those many number of addresses. So definitely some addresses will be wasted. So that's why to overcome this disadvantage problem, huge network will be divided into small networks. So we call it as subnetting. So the subnetting is a process of dividing the network into smaller networks. So while dividing the network into smaller networks, so we have to divide that into 2 power something. So let us take host address will be there. From the host part, if you consider 0 bit means no bits, 2 power 0 means there will be only one network. From the host part, if you consider 1 bit to divide the network, so then 2 power 1 2 means network will be divided into 2 parts, means 2 subnetworks. If you consider 2 bits from the host ID, then 2 power 2 network will be divided into 4 parts, means 4 subnetworks. So likewise, we have to divide network into subnetwork. The process of dividing the network into subnetworks is known as a subnetting. Let us take this example. This is class C address because 200, it is in the range 192 to 223. So that is 200.10.10. Up to here, anyhow 200 means this is class C address. So class C address means the first 3 bytes represents the network address. This is fixed. So last byte represents the host address. Last byte means it contains 8 bits. That's why here 8 places I have written 8 bytes. From these, 8 bits. From these 8 bits, if you consider only 1 bit as a network address, already these first 3 bytes network address, total 24. So if you consider 1 bit to divide the network, so then this 24 plus 1, total 25 bits are used to represent the network. From this host ID part, 1 bit is considered to divide the network. That's why 2 power 1. So network divided into 2 parts. So from these bits, if you consider 2 bits, then 2 power 2. So network is divided into 4 parts. 2 power 2, 4. Means 4 subnetworks. In this way, the huge network is divided into subnetworks. So now let us see with an example how this network is divided into subnetworks and how subnet mask will be used. So look at this example, same 200.1.2. 200 means this is class C address. So class C address means first 3 bytes represents network address and the last byte represents host address. So in this host address, I am considering 2 bytes. 2 bits. So 2 bits means 2 bits can be written as in the binary 00, 01, 10, 11. Only 4 combinations can be written and 4 subnetworks. 2 bits means 2 power 2, 4. So 4 subnetworks. And each subnetwork address is first one is 00, another one 01, 10, 11. So for this entire S1 network, the network address is 00. That means 200 dot 1 dot 2 dot first 2 bits 0. That is fixed. First 2 bits 0 means remaining 6 bits. Remaining 6 bits starts from the 0 to last value. Remaining 6 bits, so 6 bits 1, 2, 3, 4, 5, 6. 6 bits starts from the 0. First 2 bits will be 0 constant. And like this up to last one 0, 0. And these all are going to be 1. Last bits are going to be 1. These last 6 bits 1 means last 6 bits means from here to here. So now you add all these 1 plus 2 plus 4 plus 8 plus 16 plus this one. So this gives us our value total 63. Means here 0 to 63. So that is the range here written 0 to 63. 0 to 63 is changing, but the first part is common 0 0. For this entire subnet 1 0 0, that is common. So similarly, now up to here 63 is over. Right? Last first address is 0, last address is 63. 63 means the next address is going to be 64. So 64 means here in the binary only 6th bit is 1, remaining all 0. It is 64, next address. So next address means 0 0 1. So remaining all bits are 0. So total 8. This is 3, 5, 6, 7, 8. So this is your 64. 64 means that is coming to subnet 2. So subnet 2 address is 0 1. For all addresses 0 1. So 0 1 means here 1 should be written 0 1 and this part represents 64 network address, next address. Now look at these 2 bits. What is the value of these 2 bits? 128 plus 64. How much? 192. So that is the range here 192. First one 192. So likewise we are going on writing. Going on up to writing this entire part is 0 1. This is common for the entire subnet 2. Only these bits are getting changed. So these bits are getting changed means this is also common 1 and starts from this 0. Last one is going to be all 1s. So except this last bit, remaining all 1. So if you sum all these, you get 255. So likewise, subnet 1, subnet 2, subnet 3, subnet 4 range will be there. But for this S1, network address is 00. 00 means 200.1.2.00 followed by remaining numbers. So for this entire S2, network address is 01. Similarly, entire S3 network address is 10. So similarly, S4 11. How this range is derived, just I explained for these two S1 and S2. In the same way, range can be derived for range can be written for the S3 and S4 also. This is the way how that network should be divided. For example, you want to divide the network into only two parts. Two parts means here instead of your 2 bits are considered, instead of that you consider only 1 bit. So 1 bit means that can be written either as 0 or 1. So then 1 bit means 2 power 1, 2. So network divided into two parts. One side network address is 0, another side network address is 1. So in this way, huge network is divided into subnetworks. Now let us see, once the network is divided into subnetwork, but whenever the data is sent to this network, so then how that data will be sent to a particular system. So let us take, here is the, so this is your subnetwork divided into network divided into 4 subnetworks, and this point represents one router. So that point represents one router. So assume that I am drawing one line here, router. So from the outside, one message is sent to this network. So then first that reaches this router. So for this router, 4 subnetworks are connected. Now based on the subnet mask and destination address, this router will decide on which subnetwork destination is exist. So then that data will be forwarded to that particular subnetwork. So first let us see, this is the destination address. So by looking at this diagram, we can say that 200.1.2.20. This is class C address. First three parts represents a network address. The last part represents a host address. Means that is 20. 20 is the host address. So by looking at this range, we can say that 20 lies in the range 0 to 63. That is subnet 1 address, subnet 1 range. So definitely this 20 system is going to available in this subnet 1. Just by looking at this range and the host ID, we can decide that. So, but let us see how this router is going to know that, how the router performs operation to know or decide that this so and so destination lies in the subnet 1. That I already told you, using the subnet mask, router is going to decide on which network destination system is available. Let us see here, this is class C address. This is class C address. So class C means first 3 bytes represents network address. That's why in the subnet mask, first 3 bytes should be written as all one. Decimal is 255, 255, 255. In the binary representation, all ones. Next, this subnetwork divided into 4 parts. So 4 parts means from the host ID, 2 bits are reserved for the network address. So first 24 bits and 2 bits from the last byte. So that's why in the subnet mask, first 24 bits are 1 and first 2 bits from the host ID also 1. So total 24 plus 26, 26 bits are used for the network address. That's why in the subnet mask, 26 ones are written here. And the last 6 bits are 0. So these last 6 bits represent the host ID. So now assume that this is your destination address. So destination address means from the outside one message reached at the router with the destination address 200.1.2.20. So in this router, now bitwise operation is performed between this address and subnet mask. So look at this. This is subnet mask. This subnet mask written as it is here, and 200.1.2.20 destination address that is converted into the binary, and that binary written here. What represents 200 dot second one dot 2 dot 20. The same address converted into the binary written here. Now perform the bitwise operation between these two. Bitwise AND operation means if two bits are 1, write 1, otherwise write 0. Simple AND operation. Now after this AND operation, here we get this result binary value. So 1100, 100. So like this we get the result. So once we get this result, now convert this into decimal. You know that because as a human being we can easily understand decimal representation. So that's why. So you convert this binary value into decimal. Once it's converted into decimal, you get 200.1.2.0. So this is decimal value. So 200.1.2 up to first 3 bytes. So this is common because this is the class C address. So that's why first 3 bytes automatically represents network address. So no problem up to, no confusion up to here, first 3 bytes. Now coming to the last byte, this last byte is 0. So 0 means you convert that 0 into binary. So how many total? 8 zeros. All 8 zeros. So 8 zeros means your first 3 bytes 24 bits. First 3 bytes nothing but 24 bits network address, and next 2 bits also used for the network address. So means next 2 bits from the host ID represent subnetwork. Look at this here. This is 00, here 01, here 10, here 11. But here, as far as this example is concerned, so look at this first 26 bits represent the network address. First 24 bits means 24 bits anyhow, that is the network address of a whole network. Next 2 bits represents the subnet address. So what is the next 2 bits here? What are the next 2 bits? 00. Now where that 00 is? Here we have the 00. 00 is the subnetwork address of this one. Then router will decide that this is the destination address. So there is a system, means the destination system lies in this subnetwork S1. Then whatever the packet or data received from the outside network to this router, then this router will decide that based on these first 2 bits, 00 is the network address. 00 means which is S1 is the S1 address is the 00. 01 is the S2 address. Here we got 00. So that's why this router will send data onto this subnetwork S1. So in this way, that subnet router will find out on which subnetwork or on which network that destination lies by performing bitwise operation between subnet mask and destination address. This is the use of subnet mask and the advantage of dividing the network into subnetwork. And in that subnetworks, by using this subnet mask, bitwise operation between subnet mask and the destination address, so it can find out so on which network that destination is available. So this is about IP address, importance of IP address, and what is IP address, and what is the structure of the IP address, and what is the advantage of subnetting, and what is the advantage of a subnet mask. So I hope this video is informative. So thank you for watching.